Once again, welcome you all in the second video of Diborane. Okay, I am sure that you have watched first video and I have recorded SCO2 and other things also. Please watch those videos, subscribe, share with your friends. In this video number 2, part 2, Diborane B2H6 reactions we are talking about. So previously, if you remember, we have discussed the basic reactions of B2H6 where it forming alcohol or it is breaking esters and all those things. And we also discussed that acid halide and NO2s will not be reacting with this. We discussed the role difference between NaBH4 reaction and B2H6 reaction also in the previous discussion. Now we are moving forward and I'm taking a special case here in which I'll take a compound which is PHCPH and let's say this kind of carbon HPH. We'll take this compound and try to react with LiAlH4 and B2H6 and see will there be any difference in the answer. So this is a very important question actually, and we should learn the answer of these kind of questions in this particular video. So as we know, LiLH4 is known as Li plus and AlH4 minus, and this reaction involves H minus. So H minus attack in this particular process will happen at which place? So definitely H minus will go and attack on the places which is least hindered. So we can think about this place, and because of this the bond will break towards oxygen. So what is the result of this? Can I say the result of this could be PHC, PH, OH, and this place you got CH, HPH. Okay, so this kind of alcohol we can expect if we do the reaction in presence of LiAlH4. Now the second question here comes is what will happen to B2H6? So let's say I'll take B2H6. What will happen to that? I'll pick the same compound this time again for the reaction, but we'll see what is the difference in the mechanism part. We'll see the same compound but discuss the mechanism. So B2H6 is like this. You can say B2H6 is, you can say BH3 and BH3, something like this. Okay, so this kind of structure we have drawn. Now as we know that this acts as an electrophile, so what it will do, this time mechanism is little modified. So what is happening? This will attack on the system, and in the process what will happen? The other part will be free. So if you observe what we have achieved in this process, we get pH, CPH, O which is getting connection of BH2 like this, and O which is getting connection of these things as well, and a plus charge, no doubt. And what is coming out is BH4 minus. So the very next step, can I say this reaction is governed by a process where we have a possibility of carbocation generation. Hence, you have to be a little cautious here. The mechanisms are taking good amount of turn in this question. So BH4 minus which is available will go and attack on this place, not on the other place, right? So in the process what we can expect that this part will break here and H will join on this place, right? And later the other portion which is drawn can be eventually giving you formation of OH. So the product in this situation would be pH, CPH, H coming up here, CHPH. You observe this is OBH2, right? And at the end what we can conclude here is that this OBH2 bonds to be broken with the help of like provided things like H plus or others, and end product we can get PHCH, PH, CH, PH and OH. So look at the position of OH here and look at the position of OH here, and this is basically LaH versus B2H6. Normally you will not find this in books also unless until you search a lot. So this is very simple way I have tried to explain that the carbinol, the alcohol which are being formed in these two different scenarios are different. Okay, so B2H6 form least substituted carbinol, we can say. If you look at this reaction, it is least or less substituted carbinol or alcohol will be formed in case of B2H6, whereas in LiLH4 my answer was different. Okay, now see one more question. Let's say we have been given a double bond like this and there's a CH3 and then you are reacting with B2H6 THF followed by H2O2. So I hope we have done this thing in hydroboration oxidation process. So what will be the location of OH? OH will come at this place, right? Next point, reactions where we have some kind of epoxide group. Okay, let's say we write the heading aryl ethylate. Okay, aryl ethylate epoxide, and this is being reacting with the B2H6. So let's draw this compound first. So let's say we have, let's say, CH here. Okay, and then we are reacting with B2H6 in presence of BF3, boron trifluoride, right? So in this case, what we can expect is that OH will join at which particular location. So you know already OH will join at this place. So what's the answer for this question? We can say it will be CH2, CH2 and OH. So the difference in approach should be very clear. What is happening in which case, right? So this is very clear. Now next point you can mention, reduction of methyl cyclohexane. Very important reaction it is. Reduction of methyl cyclohexane. Let's fix a position of methyl group. Let's take 2-methyl hexane, cyclohexane. So what will happen with 2-methyl cyclohexane? It's this kind of compound. CH3 is here, double bond is at this place, and you are reacting with B2H6. So what we can expect is that this double bond will be reduced to OH, and at this place we will form a CH3, which is drawn here, right? So it's a modification in, if you see the modification is this was up, now it is other side, right? So this kind of structure you can draw. And similarly, if it is a 6-membered ring also, we can do the same thing. Next important reaction we have already discussed is formation of alkyl borane and formation of alkenyl borane. Please watch the previous video. Alkyl borane is basically if you have RCH2CH2 whole thrice B, and alkenyl is RCH double bond CH whole thrice B. So alkenyl borane, if you give H2O2 OH-, they become alkenols, which are CHOH, which will tautomerize to RCH2 CHO. Whereas in this one, if you have RCH2CH2, you get OH directly in these cases. So everything is covered earlier. You can just revise those videos. It will be very, very helpful. Now, next proceed like organic reaction in presence of compounds like alkyl chloride. So note down. Let's say we have some allylic groups also. Allyl chloride we can take example. It's a CH2 double bond CH, CH2 Cl we take. And you're doing this reaction with B2H6. So what will be expected here? That at this place you have Cl, let it be. And at this place, what are you going to join? You're going to join boron and these groups, right? Hydrogen, hydrogen. And later, if you bring sodium hydroxide, let's say. So what is the role of sodium hydroxide? Sodium hydroxide in condition to remove the Cl, put O- at this place. And we can expect some SN and GP reaction where 1, 2 and 3 things can club. So it can give you formation like cyclopropane. So these kind of reactions are basically example of SN and GP processes, and this will result into cyclopropane kind of structure. So you can do such reactions also using allyl chloride. I hope it is clear. So please revise everything. This is a very useful video. Keep liking and don't forget to subscribe. Thank you very much.